Hello and welcome to the Flat Earth, a Cavalcade of Stupid. This is the first of what I hope won't need to be many more of these videos debunking the idiocy of the Flat Earth. These things take forever to research and write, and quite frankly, I don't have enough respect for you jackasses to spend a lot of time on them. Normally, I'm quite content to let people wallow in their own stupidity, but in this case, people who might not know any better may actually believe their bullshit. In fact, a 2016 National Science Foundation survey found that nearly 1 in 4 Americans don't know that the Earth revolves around the Sun. Thankfully, in Canada, it's only 13%. In fact, Canada outscored the United States on nearly every question in the survey. Before I dive in, I should mention a few things. First, there will be math. Lots of math. If you have a problem with that, too bad. You can't do science without math. Second, I will be showing clips and stills from other people's videos. This is done under fair use provisions under Canadian copyright law. Third, I'm Canadian, so I'll frequently be using metric measurements. If you have a problem with that, too bad. Fourth, I consider it perfectly reasonable to call you a moron if you say moronic things. Fifth and finally, flatheads say moronic things. You are morons. Before I begin dealing with the specific claims of the flatheads, I'll need to derive some equations that I'll be using throughout this video. You're free to use these equations all you want. In fact, I encourage it. I warned you, there will be math. The first equation I need is one to give the maximum distance from which an observer can view an object. I know there are a lot of flatheads who have tables from which they like to look up distances, but most of them have no idea what the numbers actually mean or how to use them. More on that later. There's that moron word again. On a sphere, yes, a sphere like the Earth, the line between the object and the observer will be tangent to the sphere and, as such, perpendicular to a line drawn from the tangent point to the center of the sphere. This results in a pair of right triangles, so we just need to use Pythagoras' theorem to solve our distances d1 and d2, then the total distance will simply be d1 plus d2. As you hopefully remember from grade school geometry, for a right triangle, the square of the length of the hypotenuse, in this case r plus h1 for the observer and r plus h2 for the object, is equal to the sum of the squares of the two other sides, in this case r and d1 for the observer, r and d2 for the object. This gives us a pair of equations. Here's where the fun begins. The first thing we need to do is expand the squares on the right-hand sides of the equations. The r squareds on both sides of the equations cancel each other out, giving us a pair of equations for d squared. Next, for simplicity, I'll assume the heights are small compared with the radius of the Earth, up to a couple hundred kilometers, so I can ignore the terms in h squared because they're very small. This isn't a necessary step, but it makes the math easier. Next, we can get the total distance by taking the square roots of these equations, adding them together, and taking out the common factor of root 2. Finally, substituting in the radius of the Earth, adjusting our units so that heights are in meters and distances are in kilometers, the root 2r term becomes approximately 3.57. So, distance is approximately 3.57 times the square root of h1 plus the square root of h2. Or if you prefer working with feet and miles, it's about 1.225. Again, I emphasize that this is only for heights that are small relative to the diameter of the Earth. I know that many flatheads like their equations stating that the horizon drops a distance of 8 inches times the distance in miles squared, even though they're too stupid to recognize that this is only for small distances and heights, a couple hundred miles. I leave it to you to do the math to show that my equation is a more generalized version of this. Let's work out an example. Consider someone 6 feet tall looking at another person 6 feet tall. How far apart can they be and still see each other? The square root of 6 is approximately 2.45. Double this, multiplied by 1.225 gives approximately 6 miles. When flatheads look at their beloved tables, or use their 8 times distance squared equation, the number they're getting is the distance from the tangent point to either object or observer. So, for example, when a table says that an object 10 kilometers away is 7.85 meters below the horizon, this would be if the observer is at the level of the horizon, h1 equals 0. If the observer is 1.7 meters tall, h1 equals 1.7, the distance below the horizon drops to 2.24 meters. One caveat to this that I should mention is that this distance is only approximate because it will depend on the surface over which you're looking. For example, the air above cold water will be cooler than the air higher up. This will have the effect of refracting the light slightly downward, allowing you to see further. Similarly, looking over a hot surface, a road for example, will cause the air to refract the light up slightly, decreasing the distance you can see. Also, and I shouldn't need to mention this, but you people are so dumb that I probably need to, if there's an obstacle in the way, you won't be able to see through it, so the viewable distance becomes less. The next equation to work out will be how far the horizon will be below a horizontal line. Consider a person with height h standing on the surface of the spherical Earth looking exactly horizontally. I'll call the angle between this horizontal line and the line from the person to the horizon theta. I'm using theta because my background is in physics, and in physics, angles are Greek letters, usually theta. To find the angle, the first thing I will do is draw a line from the center of the Earth to the person, and another line from the center of the Earth through the tangent point up to the horizontal line. The important thing to notice is that the second line is perpendicular to the tangent line, resulting in two similar triangles. Because of this, the angle between the two lines that I've drawn from the center of the Earth will also be theta. So, I have a right triangle. One of the sides is the Earth's radius r, and the hypotenuse is r plus the person's height h. From this, we can work out the angle. If we consider an airplane at an altitude of 10 kilometers, approximately 33,000 feet, this angle is approximately 3.2 degrees, a small angle. Knowing that the angle is small, we can simplify the equation. First, I'll do a Taylor expansion of the cosine. For this equation, theta is in radians. I'll convert back to degrees later. I know this looks more complicated, but trust me, it will end up much simpler. Since we know that theta is small, terms beginning from the fourth power onward are negligible and can be ignored. Also, 2 factorial is equal to 2, so for small angles, this equation reduces to cos theta equals 1 minus theta squared over 2. Now I can substitute this back into my original equation, evaluate for theta, and find the common denominator inside the parentheses. The r's in the numerator cancel out, and since the h in the denominator is small compared to r, it can be ignored. This gives us theta is approximately square root of 2h over r radians. Finally, we can isolate h by removing the root 2 over r, convert back into degrees by multiplying by 180 over pi, and then substitute in the radius of the Earth. I told you it'd be simpler. If we look again at the example from earlier with the airplane at an altitude of 10 kilometers, this again gives us an angle of 3.2 degrees, so my approximations are valid. In fact, this approximation is still reasonably accurate for much higher heights. At a height of 1,000 kilometers, for example, the equation gives an approximate angle of 32 degrees, while the actual angle is 30.19. This is still a reasonably good approximation. Let's look at some of the supposed failings of the spherical Earth model. Flatheads come up with all kinds of nonsense that they claim proves the Earth is flat. It's all bullshit. Unfortunately, if I attempt to refute all of their bullshit, this video would go on for months, so I'll only look at a couple of the big ones. First, why doesn't the horizon look curved? If the Earth is a sphere, the horizon should be curved. Secondly, why can I see things that are very far away? According to my tables, things should be hundreds of feet below the horizon. Third and finally, if the Earth is spinning at 1,000 miles per hour, why don't things fly off of it? First, let's look at the curved horizon. Consider this photograph that I took. A flathead will say, "See, the horizon is flat, the Earth is flat." This, on the face of it, sounds plausible. The question remains, if the Earth is round, how much curve should we see? Let's find out, shall we? So, how much curvature should I see? Or, more precisely, how many pixels lower should the horizon be at the edge of the photograph than at its center? To evaluate this, the first thing I need to know is the angle between a horizontal line and the horizon. Well, I've already given the equation for that. Theta is approximately 0.032 root h. I'm approximately 10 meters above the surface of the water. Probably less, but it doesn't really matter. So this gives an angle of just over 0.1 degrees. Now comes the tricky part. If the camera is looking at a downward angle toward the horizon, we can extend the line of sight backward and take the angle between that line and another line angled down toward the horizon. The angle between those two lines will simply be twice the angle between the horizontal line and the horizon, or 0.2 degrees. Now, let's say we have a hypothetical camera that has a full 360-degree field of view. How many pixels lower would the horizon be behind the camera than in front of it? Well, we know the angle would be approximately 0.2 degrees, The photograph was taken using a 17mm lens, which, according to Canon, has a diagonal field of view of 78 degrees. This translates to a vertical field of approximately 47 degrees. This means that the horizon drops by approximately 1/235th the height of the frame. The photo is 3328 pixels high, so the number of pixels it would drop is approximately 14. Note that this is if I had a full 360-degree field of view. I don't. I have a horizontal field of view of 62.4 degrees, or from center to edge, 31.2 degrees. The number of pixels down would be approximately 14 times 1 minus cos phi over 2, or 7 times 1 minus cos phi, where phi in this case is the angle from the center of the photograph to the edge. For 31.2 degrees, that would be 1.01 pixels. We'll call it 1 pixel. I hate to break this to you, well, I don't really, but this is imperceptible. For anyone who wants it, here's the more general equation for this. The second supposed failing, why can I see things that are far away, is even easier. Let's look at a couple of representative examples. There's a video from a guy who, ironically, calls himself Know the Truth, in which he shows a number of lighthouses and things he claims shouldn't be visible. These are based on the book by a dumbass named Eric Dubay called 200 Proofs the Earth is Not a Spinning Ball. I'm obviously not planning on going through all 200, but here are a couple of the really blatant ones. In this first example, Eric claims that at a distance of 35 miles, the curvature of the Earth is 490 feet, so since the lighthouse is only 150 feet above the water's surface, it shouldn't be visible. Doing the math, this would mean that someone needs to be 266 feet above the water to see the lighthouse at that distance. Sounds like a problem, except, according to the Newfoundland and Labrador pilot by the Great Britain Hydrographic Department, the lighthouse is only visible from 16 nautical miles, approximately 18.4 statute miles. So, doing the math, you would need to be approximately 7 foot 8 above the water's surface. So, in a boat. In an even more blatant lie, Eric says that the Port Said light has an elevation of 60 feet. One look at the buildings surrounding the lighthouse tells you that this is bullshit. The apartment building beside the lighthouse looks about 60 feet tall, 6 stories, 10 feet each. Wikipedia, admittedly not the most reliable source, gives the height of the lighthouse above the water as 59 meters, 194 feet, or more than 3 times as high as Eric claims. Also, the range is only 25 miles, not 58. Using these numbers, we find that someone would only need to be 42 feet above the water's surface to see the lighthouse. This is typical for any large ship of the sort that would need to be aware of land from that far away. But rather than look at individual lighthouses and showing why Eric's numbers are complete nonsense, we need to ask a much more basic question. Why are lighthouses built tall? If the Earth was flat, a lighthouse would only need to be taller than the surrounding buildings to be visible, and, since they're usually built on rocky outcroppings where there are no other buildings, there's no need to build lighthouses taller than about 20 feet. On a round Earth, however, a taller lighthouse will be visible from a greater distance. Another claim flatheads make is, if the surface of the Earth is spinning at 1,000 miles per hour at the equator, why don't things fly off of it? Or any number of variations on this premise. To answer this, I feel compelled to invoke what appears to have become the de facto standard video response to this type of question. Take it away, Desert File.
Gravity, you fucking retard! Gravity! Have you ever heard of fucking gravity? Gravity! Gravity!
If you don't like that answer, we can, once again, turn to our good friend math. Centripetal acceleration is the velocity of the object squared divided by its distance from the center of rotation. Also, the velocity that something travels is its distance traveled divided by the time. In this case, time is the length of time required for one rotation, 24 hours, and the distance is the circumference of the Earth at the equator, 2 pi times its radius. Combining this, we get that the acceleration is 4 pi squared r over t squared. R is the radius of the Earth, approximately 6.371 times 10 to the 6 meters, and t is the number of seconds in a day, 86,400. Plugging in the numbers, this gives us an acceleration caused by Earth's rotation of 0.0337 meters per second squared. Acceleration due to gravity is approximately 9.81 meters per second squared. This means that the acceleration caused by the spinning of the Earth is a little over 0.34% of the acceleration due to gravity. It's negligible. I've also heard flatheads say inane things like, "It doesn't feel like I'm moving 1,000 miles per hour." Really? What exactly would that feel like? I've frequently been in airplanes traveling over 600 miles per hour, and that doesn't feel any different from standing on solid ground. Don't waste people's time with that kind of bullshit. Next, let's look at some of the many places where the flatheads' claims fall down. Flatheads like to call their nonsense a theory, so let's treat it as one. Unfortunately for them, in science the word theory does not mean hunch or speculation or guess. In science, a theory is an explanatory framework that makes testable predictions that have been confirmed through experimentation. Fun fact, the person proposing the theory is not the only one who can make predictions. If anyone makes a prediction that is consistent with the theory, but not consistent with reality, the theory needs to be either revised or abandoned. So let's see what kind of predictions their theory makes. According to the flat Earth theory, the Sun traces a circle approximately 3,000 miles above the surface of the Earth. This means that if the Earth was flat, the Sun should always be visible. Flatheads invariably come up with some claptrap about it being perspective, but never provide any math to back up their claims. Well, guess what? That's right, more math. The circumference of the Earth at the equator is approximately 25,000 miles. This gives us a diameter for the equatorial disk of approximately 8,000 miles. Exact numbers here aren't necessary for a reason that will soon become apparent. At the Tropic of Capricorn, the diameter of the circle that the Sun circumscribes is about 12,000 miles. Assuming the Sun to be 3,000 miles above the Earth, we have a right triangle with 3,000 mile and 12,000 mile sides. The angle between the horizon and the Sun will be the inverse tan of 3,000 over 12,000, or about 14 degrees. So, for an observer at the Tropic of Capricorn, the Sun would never drop below about 14 degrees above the horizon during the winter solstice. The situation is even worse if we look at the summer solstice from the northern hemisphere. During the summer solstice in my home in Toronto, the Sun would never drop below about 30 degrees above the horizon. Out of fairness, let's assume that I've underestimated the diameter and hence the horizontal distance to the Sun. Instead of the Sun being 12,000 miles away, let's say it's 20,000 miles. Hell, just for shits and giggles, let's say 200,000 miles away. Remembering our grade school geometry, we know that the law of similar triangles would put the Sun on the same line of sight as a structure 30 feet tall and 2,000 feet away. This is equivalent to a house less than half a mile away. Is anyone seriously going to tell me they can't see a house from half a mile away? Given this, the flat Earth theory fails to predict reality. The model predicts that the Sun should always be visible. Clearly, it is not. Flatheads get around this by saying the Sun becomes obscured by the atmosphere and that causes it to become invisible. Well, there's some problems with that too. First of all, if this was the case, the Sun wouldn't set, it would just fade. But it gets worse. Consider the winter solstice. The Sun follows a path shown by the green line. A person at the North Pole has 24 hours of nighttime. The red line shows where the Sun is relative to that person at the North Pole. Now consider a person in Australia, where the red line and the green line intersect. At noon, the Sun would be directly overhead. This is consistent with both models. How would this look at 6 p.m.? The person at the North Pole would still have nighttime. The distance from the North Pole to the Sun, shown by the yellow line, will be the same as the length of the red line. What would the person in Australia see? I was there in February. Sunset is approximately at 8 p.m., so at 6 p.m. it was daylight. The distance to the Sun is shown by the blue line. These lines give us a handy right triangle and tell us that the Sun is visible to the person in Australia, even though it's approximately 40% farther away than the distance to the North Pole. So, according to the Flat Earth model, the person at the North Pole can't see the Sun because reasons. Things get even worse for the flatheads during the summer in the Northern Hemisphere. Consider the sunset in Toronto during the summer solstice. The Sun's path is shown by the green line. Its intersection with the red line shows the position of the Sun at noon in Toronto. It will appear in the south as predicted by both models. On the summer solstice in Toronto, sunset is around 9 p.m. daylight savings time, 8 p.m. standard time. The yellow line shows the position of the Sun at 9 p.m. The blue line shows the direction that I would need to look to see sunset. That's right, according to the Flat Earth model, I would need to look in the northwest to see the sunset. In reality, I see the sunset a little south of west. This prediction doesn't conform to reality. The flat Earth model fails. Let's look at another fail. Earlier this year, I flew from Sydney, Australia to Auckland, New Zealand. This distance, as measured on Google Earth, is 2,163 kilometers. The flight took 3 hours, so my average speed was 721 kilometers per hour. If we assume 15 minutes for taxiing, takeoff, and landing, the average speed of the airplane would be 787 kilometers per hour. This is normal for a Boeing 737. Am I the only one bothered by an airplane called Boeing? I guess it's better than Splat, but I digress. Let's see how the flat Earth handles this one. The first thing we need to do is calculate the distance from Sydney to Auckland on a flat Earth. Sydney is located at 33 degrees 57 minutes south by 151 degrees 10 minutes 37 seconds east. Auckland is at 37 degrees 29 seconds south by 174 degrees 47 minutes 20 seconds east. If we look at this on the flat Earth, we can draw a triangle with vertices at the North Pole, Sydney and Auckland. Where the green line is the distance from Sydney to Auckland, the angle between the red lines is the difference in longitudes between Sydney and Auckland, which is 23.61 degrees. Next, we need to calculate the distance from the North Pole to Sydney and Auckland. Let's do Sydney first. The first thing we need is the distance from the North Pole to the equator. The circumference of the Earth is approximately 40,000 kilometers. Divide this by 2 pi gives a distance of 6,366 kilometers. That's a latitude of 90 degrees. Sydney is nearly 34 degrees past this. From this, we get the distance to Sydney. Plugging in numbers, we get the distance from the North Pole to Sydney is 8,766 kilometers. Using a similar calculation, the distance from the North Pole to Auckland is 8,982 kilometers. Given these values, we can use the cosine law to calculate the distance from Sydney to Auckland. So, the distance from Sydney to Auckland, according to the flat Earth model, is 3,637 kilometers. If we divide the distance by 2 3/4 hours, like we did for the spherical Earth, we find that the airplane would need to travel at a speed of 1,323 kilometers per hour. The speed of sound is only 1,234 kilometers per hour. A Boeing 737 is not a supersonic aircraft. Now, I suppose flatheads will be yammering some kind of bullshit that a 737 is supersonic, but the knowledge is being expressed by the big bad government, or NASA, or the Illuminati, or whoever the latest boogeyman might be. But to claim this would require that every airline, every aircraft manufacturer, every aerospace engineer, every pilot on the planet, as well as people from a huge number of other fields, is in on this conspiracy. How about we narrow things down a bit? Why don't you tell me who's not in on this vast conspiracy of yours? Well, maybe it's not a vast conspiracy. Maybe it's just a half-vast one. Enough dealing in generalities. Let's look at a couple of the players in this badly acted farce that is the flat Earth. I've already mentioned Eric Dubay, but a lot of devoted flatheads think he's a shill trying to discredit the whole flat Earth claim. I don't know if he is, and I really don't care. Flatheads do a good enough job discrediting themselves every time they open their mouths. That said, the first clown in my cavalcade of stupid calls himself Mr. Thrive and Survive. Everyone is allowed to be an idiot, but this guy abuses the privilege. It's difficult to decide if he's doing this ironically or if he really is quite monumentally stupid. I suspect the latter. This guy is such a cornucopia of stupid that it's tempting to do an entire video dedicated just to his unique brand of stupidity. As tempting as it is, however, there's just so much stupid and so little time. Because of this, I'll only pick out a few of the most moronic babblings from the Thrivemeister. Choosing a single video to mock is a difficult task because he's put out so many and each is as stupid as the last. So, for simplicity, I've gone into his channel and chosen one at random. Let's have a look.
45-degree angle. So every 3 hours you get a 45-degree angle of the sun on the Earth. I hope that's clear. All right. Which is 3,000, 3 time zones is 3,112 miles apart. All right. One time zone is 1,037 miles apart. That's where I made a mistake. Sorry about that. So each time zone is 3,000 each 3 time zones is 3,112 miles apart. And at 3,112 miles apart, you should see the sun at a 45-degree angle, and you will. And we have 24 time zones around the Earth. Okay? Very good. All right. I don't think any of this is disputed at all. Now it's time for 4th grade people today, probably. And this is, again, this is the low-grade version of the NASA Paint software.
Yada, yada, yada. Basically what he's saying is that in order for the sun to be at a 45-degree angle, it would have to be only 3,112 miles above the surface of the Earth. There's so much stupid going on here, it's difficult deciding where to begin. First, let's see why this wouldn't work for a flat Earth. By Thrive's reasoning, at 3 time zones away, the sun should be at a 45-degree angle from the vertical. This would only be the case on specific days which are dependent upon his location. For simplicity, let's use the equator during an equinox. The circumference of the Earth is approximately 24,900 miles at the equator, so 3 time zones away would be 3,112 miles, forcing the sun to be 3,112 miles above the Earth. This is where old Thrivey gets his number. There's a problem with this. For someone only 2 time zones away, by Thrive's reasoning, the sun should be at a 30-degree angle from perpendicular. This would make it 3,608 miles above the Earth. 1 time zone away would be 3,887 miles. It seems we have a bit of a problem. The sun is simultaneously 3,112, 3,608, and 3,887 miles above the Earth's surface, and, depending upon where you are, anywhere between these values. Now, let's look at the sensible spherical Earth model. At noon, the sun is on the perpendicular. For a person 3 time zones away, the sun is 45 degrees from perpendicular. You'll get similar results for any angle. Much simpler, the numbers work, and it doesn't require any special relationship between the radius of the Earth and the distances to the sun. A sphere just works. Up until now, I've been accepting Thrivey's assertion that at 3 time zones away, the sun will be 45 degrees from perpendicular. Unfortunately, for a flat Earth, this is not the case. Consider someone standing on the Greenwich meridian at the equator at noon during the equinox. The sun will be directly overhead by either spherical or flat Earth models. Now, that person waits 3 hours until the sun is, according to the spherical Earth model, directly west at 45 degrees. Where will it be according to the flat Earth model? The horizontal yellow line is an east-west line as seen by that person on the Greenwich meridian. The angled yellow line is the direction that person would need to look to see the sun at 3 p.m. Instead of looking directly west, the person would need to look west-northwest at 22.5 degrees. Flat Earth fails again. Recently, Thrivey has come out with a new, undebunkable proof that the Earth can't be a sphere. It is, as can be expected, laughable. But how about I let him explain it in his own words?
As you can see here, this is the exact model we would use in the summer in the Northern Hemisphere. Above the Arctic Circle, which is represented by this top blue line, as the observer would leave dark and come into sun, they would be at the highest point of the day because the Earth is tilted down. As the observer heads towards noon, which would be at this position here, closest to the sun, they would not only be falling in respect to a position in space, but they also would be going down in tilt. Whenever you go down in tilt and lower your position in space both, an object such as the sun in the distance, no matter how far, would necessarily have to rise.
Blah, blah, blah. Basically, the straw man that Thrivey is presenting is that the sun appears to rise and set because we are moving higher and lower relative to it. See the problem? No? How about I draw the Earth, Sun, and distance between them to scale? Unfortunately for the Earth to be visible, barely, I had to draw it 10 times larger than it should be, but you get the idea. Is the problem starting to sink in? That's right, the difference in angle caused by the person moving higher and lower relative to the sun is negligible. How negligible? Let's work that out. Given the approximate 23-degree axis angle and a radius of 4,000 miles, once again exact numbers aren't that important, the total amount of height the person descends is the radius of the Earth multiplied by sine 23, which is 1,563 miles. Divide that by 92 million miles to the sun, take the inverse tangent, and you get an angle of just under 1/1000th of a degree. So, by Thrivey's reasoning, Over the course of a day, from sunrise through the afternoon and into sunset, the sun rises and falls less than 1/1000th of a degree. So, what really causes sunrise and sunset? It's truly painful that I need to explain this. It's a horrifically damning indictment of the American education system, but I do what I must. For simplicity, let's once again use the equator during an equinox. The sun is big enough and far enough away that I can treat sunlight reaching the Earth as parallel rays of light. A person at sunrise sees the light tangent to the surface of the Earth. At noon, the sunlight is perpendicular to the surface of the Earth. Finally, at sunset, the sunlight is once again tangent to the surface of the Earth. In other words, the person sees the sun rise at the horizon, pass directly overhead, then set again on the opposite horizon. Sound familiar? Wow, disproving Flathead's undebunkable proofs is embarrassingly simple. Hey Thrivey boy, you seem to like experiments, here's one for you. It's very simple, it doesn't take long, it'll only cost you the price of a couple gallons of gas. From watching your videos, I've gathered that you live in the Phoenix area. That's handy because Phoenix has a lot of long straight roads going east to west. Specifically, I'll assume you're familiar with Bell Road. The distance along Bell Road from North 64th Street to Bob Stump Memorial Parkway is, according to the correct spherical model, 27.4 miles. The farcical Flat Earth model predicts 20.6 miles. Take a drive. To be fair, Thrivey is one of the more entertaining flatheads. He at least spouts original bullshit rather than others who just repeat the same brain-dead claptrap over and over again ad nauseum. Next up, Flat Earth Hub. I found a hilarious video from Flat Earth Hub. They, I don't know, really shoot themselves in the foot with this one. Basically, this is one of the cliche camera going up in a balloon videos that flatheads seem so fond of. Maybe it's a rocket, I don't know, doesn't matter. At the start of the video, it's specified that this is a normal camera, as opposed to, I assume, a fisheye lens. Before I continue, a quick word on fisheye lenses. Anytime flatheads think they see a curve on the horizon, they immediately scream fisheye lens. Yes, a fisheye lens will create a curve where none exists, but they do it in a very specific way. Any line below center frame will be curved up, any line above center frame will be curved down, a straight line going through center frame will remain straight. More generally, a straight line going through center of an image will remain straight regardless of its angle. Keeping that in mind, let's enjoy the view. Well, we're nice and high up. If the Earth is a sphere, we should see a curve on the horizon, so let's grab a frame. Well, their image is a little blurry and indistinct, so let's increase the contrast a little. That's better. Now just draw a line across the horizon, and oh dear, there is a definite curve. The horizon is at center frame, so clearly this isn't some kind of fisheye effect. The only thing we're left with is an actual curve from a spherical Earth. Now, before you flatheads blurt out your usual bullshit about being fake NASA CGI, keep in mind that this video is recorded and presented by one of your own, trying to prove the Earth is flat and doing a shit job of it. Since I'm such a nice guy, I'll offer you a freebie. Despite your protestations, there are many photos on the internet that show bottoms of objects hidden below the horizon while their tops are visible. I'll offer you an explanation for this that is consistent with your flat Earth model. If you remember back to an earlier segment in this video, I showed you a diagram of light bending around the curved Earth. How would this look on a flat Earth? The light is curved down and doesn't make it all the way to the observer. What if we use a taller object? Well, that's interesting. Light from the bottom of the ship doesn't make it all the way to the observer, while light from higher up does. The bottom of the ship will seem to have disappeared below the horizon. Of course, this explanation is hopelessly and irretrievably flawed, but that's never bothered you flatheads in the past. Why should it bother you now? Well, I hope you enjoyed my little foray into the idiocy that is the flat Earth. If you did, hit that little like button. If not, you can saw it off. Feel free to leave a comment. If it's interesting, I might respond. If it's not, I probably won't. And if it's an ad hominem attack, I'll probably just delete it because you're a tool. If you have suggestions on what conspiracies I should cover in future videos, leave them in the comments. I'll consider doing videos on Hollow Earth, Mandela effects, or nearly any other topic. Till next time, remember, if it looks like bullshit and it smells like bullshit, it's probably bullshit.